Hello and Namaste. In continuation with the probability distributions, we are going ahead with the normal distribution, different problems, and this is the part 1 we are dealing here with. Now, this particular slide I have kept it purposely so that you can just refer it. We are going to go ahead with the problems based on this normal distribution. Every variable we are trying to convert to the standard normal, and then we are going to use this table values, or you can say our probabilities from the table values. Now herein, rather than to show this entire table every time on the slide, it's difficult to fit the content of the problems as well as the solution as well as this table. So what I'm going to do it, suppose I need to have the probability or the value at 0.67. So I'll be just showing this Z, and I'll be showing this particular column, that is 0.07. Under that the value of this. So I'll be showing you just 4 things, that is of this one, this particular one, this particular one, and this particular one. And that means what this is, we are going to say the value at Z equals to 0.67 as 0.2486. So this is what we are going to use it. I'll be taking only this much of screenshot from this particular value and I'll be showing you the table values. Okay. If capital X and Y are independent random variables, each following this normal distribution with 0, 3, what is the probability that the point lies at X, Y lies between the lines 3x plus 4y is equals to 5 and 3x plus 4y is equals to 10. Now again the same thing, as because of the additive property of the normal distribution we have already seen. Please reach through to the previous session with this I button, wherein we have introduced in a detail about the normal distribution and different properties. Therein we have discussed about the additive property also, and we will be using this additive property directly over here to find out, because as we need 3x plus 4y, so we are saying that u is equals to 3x plus 4y. We have got the normal distribution, the mean of the distribution, that is replacing this x with the mean of x and replacing as y mean of the y, which is 0 in both the cases, if you observe here. And to get the value of this sigma over here, we need to have this, replace this x by the square of this 3, that is 9. This 3, this y is also a square of this, we are replacing it as, and this 3 and y 4 will also be giving you the square, so it's nothing but square root of 9 into 9 plus 16 into 9, so it's nothing but this, just a minute, this is nothing but 3 square x square plus 3 square y square. So it's nothing but that x we are replacing that 3, y is replacing as this 3. So we will be getting the value, or you can say this particular u follows normal distribution with 0, 15. So the point x, y lies between these two, that is a 5 and 10. That means this is probability 5 less than 3x plus 4y is less than 10. But this 3x plus 4y, we have said that okay, that is nothing but some u over here, which is we have defined, and therefore we have to convert this u into the normal or a standard normal distribution. What is that? That z equals to x minus mu upon sigma follows the normal distribution with 0, 1 as the parameters. So therefore we are going to use this particular, or we are trying to convert this u in terms of z using this 5 minus 0 upon 15, u minus 0 upon 15. So u minus 0 upon 15 will gives us this z, and this 10 minus 0 upon 15. So this is nothing but is getting reduced to this. So that is not, this is nothing but a z we are reducing to. So standard normal distribution. So this p lies between 0.33 to 0.67. If you'll observe the figure, that means what we need to find out the probability between 0.33 to 0.67. That means we need to find out the probability or area of this particular shaded region. Now if you'll observe here, in the standard normal table, the values has been given to us as from 0 to the point. So this is nothing but probability of 0 less than z less than the z1 values has been given to us in the statistical table, and that's the reason this particular value we can have it as 0.67. So we'll be taking this 0.67, the entire probability, minus 0.33. So we'll be taking in this way, and if you'll observe here, oh just a minute, I'll just erase this off. Yeah. So if you observe here, this is nothing but 0 to 0.67 minus 0 to 0.33. If you observe, we have the value for this from the statistical normal statistical table. We can have it as At the value 0.67 we have got the value as 0.2486, and at 0.33 we have got 0.1293, and if we'll subtract these values we'll be getting the particular this shaded region, the or area, or you can say a probability as 0.1193. So this is what we are going to get it in this type of examples, and this is the way I'm going to show you the values from the statistical table rather than to show the entire table over here. That won't fit. So we will be just going with the values which all we needed. But yes, definitely I'll be showing you this column as well as the row from where you are. So this is a row 0.6, column as 0.07. Similarly 0.3, 0.03 from this particular. I'll be giving you the soft copy of this particular table in the description section below. Okay. Going ahead for the next, the independent random variables x and y have the distributions n45, 2 and n44, 1.5 respectively. What is the probability that randomly chosen values of x and y differ by 1.5 or more? So we have to form here the statistical, you can say a mathematical formula using this. Let us go ahead step by step. Now again, x follows normal with 45, 2, y follows 44, 1.5. So u is nothing but x minus y, because we can, why are we going for this u as x minus y? Read the statement. What is the probability that randomly chosen values of x and y differ? That means what? We have to write down the difference as the variable. So that is the reason we have said that u is equals to x minus y, which follows the distribution the same way additive property what we have used in the last. Again, my suggestion is please reach to the I button for the details about the additive properties and all. So this is giving you n as 1 comma square root of 4 plus 2.25, which gives us normal distribution with 1 comma 2.5. Now if you'll observe here, what exactly we needed, x and y differ by 1.5 or more, means in a mathematical term, because it's a difference between them is greater than or equals to, so it's a mod of x minus y is greater than or equals to 1.5. This gives us mod of u is greater than or equals to 1.5. That is nothing but, because it's very difficult for us to go ahead and find out mod of u is greater than or equals to 1.5. So it's simple for us to go ahead and find out 1 minus probability of mod of u is less than or equals to 1.5. So we have used the property of probabilities. Therefore this is nothing but, if you'll observe here, it's a mod of u is less than 1.5. That means what? We have got the value of 1.5 as minus 1.5. So that means what? Which is u lies between. So if mod of u is less than or equals to 1.5 means what? This u lies between minus 1.5 to 1.5. This is the property of inequality using the modulus. Therefore this is nothing but, again we are trying to shift it, this particular u, to a normal z x minus mu upon sigma follows normal 0, 1. Therefore this particular value will be going to get it as minus 1 less than or equals to z less than or equals to 0.2. That means we need to have the value from minus 1 to minus 2.2. So we need to have this shaded area from this particular thing. But if you'll observe in a statistical table, we have been given the values from 0 to, so only positive z we have been given the values in the statistical table. But yes, because of the symmetricity we can draw, or you can say that this particular figure you can draw it in this way, which is from 0 to 0.2 and then 0 to 1. That means because of this symmetricity we can write down minus 1 is less than z is less than 0.2 can be written as probability of 0 is less than or equals to z is less than 1 plus probability of 0 less than z is less than 0.2. That means we are taking the probability from here to here as well as point from here to here to get the value, to get the shaded region or shaded area of this particular. Now again, the value of z at 1 is given to us 0.3413. This is the value at 1, and at 0.2 we have got the value as 0.0793. If we'll add them up, we are going to get it, and we'll subtract it from 1. We'll be getting the value of this particular shaded area as 0.5794. And then from this particular we are subtracting this particular area from 1. that will gives you the value of this probability of mod of, or otherwise you can say x and y differ from by 1.5 or more. This type of way you have to go ahead and solve the examples of modulus. Now let us go ahead and find out one more. The marks obtained by the students in mathematics, physics and chemistry in an examinations are normally distributed. Now from here we can understand that this particular distribution we have to follow the normal with means 52, 50 and 48 with standard deviations of 10, 8 and 6 respectively. Find the probability that a student selected at random has secured a total of 180 or above and 135 or less marks in the exams. Okay, now let x, y, z be the marks obtained by students mathematics, physics and chemistry respectively. Again, that means x follows normal with 50 to 10, y follows with 50, 8, n follow this, or z follows 48 by 6. By the additive property of normal distribution, t is nothing but x plus y plus z follows the normal distribution. Now why are we going for this particular t variable, or we are defining the variable t, which is the addition of 3 of them. Find the probability that a student selected at random has secured total of. So we are not talking here about mathematics, physics and chemistry individual. So that's the reason we have to have the total of them. Therefore we have to take, or we have to define another variable known as t. Say for example t, you can take any alphabet, it's just a label for the variable. So it's x plus y plus z, so we have to have the addition of 3 subjects. So mathematics, physics, chemistry. So this is a new variable we are defining. As we are defining a new variable, we do have to have the normal distribution. What is that? The addition of mu, that is 52 plus 50 plus 48, that will gives us the mu of the new distribution, or t, with 150, as well as the standard deviation. If you observe here, it's been taken to as a square root of, that means whatever the value we got it as, that is the standard deviation, that is 14.14, which is the 10 square plus 8 square plus 6 square, this root of that will gives us this. So this is nothing but a sigma. So if you'll observe here, the secured 180 or above, so probability of t greater than or equals to 180, that means nothing but we are trying to convert this t in terms of a standard. So now if you'll observe here, it has been given to t is greater than or equals to 180, means it is understood this is nothing but the probability of infinity is greater than t is greater than or equals to 180. That is what we have done it here in this case. So that is, this is nothing but 180 minus 150 upon 14. So I have just taken the equality in opposite sense, which is giving you something like this. That means we are trying to convert this particular t into a standard z, standard or standard normal. That would gives us the value 2.12 is less than z is less than infinity. And if you observe in the standard normal curve, these are the points which are, all of them are greater than 2.12. So all this z which are greater than 2.12 is nothing but this shaded region. Our target is to achieve, or our target is to find out the area or a probability for this particular shaded area. Now again, because as this particular curve is symmetric, we have already discussed it this. So this particular half part is nothing but total is 0.5. If I need to have this particular area, we do have to subtract this from 0 to 2.12 area. So we need to have, or if I, that means what this is, this area is nothing but 0.5 minus probability of 0 less than z less than 2.12. So this is what we are going to get it. So total area, total half point is 0.5. So 0.5 minus probability is 0 is less than z less than 2.12. That would gives us, now the value of z at 2.12 is, this is 2.1, and column 0.02 will gives us 0.4830 as the value. So we are going to get the value of this particular small part is 0.0170. This might be looking little bigger, but yes, it is very small area. That is because if you observe the value, it's a 0.0170 for this particular area. So this is what all about the question number 3. A. first part. Now if you observe probability t less than equals to 135, that is what all the values which are less than the 135 answer, or you can say the addition. So again we are trying to convert this into the z, and if you observe here we have got minus infinity, because as I have told you, though it is like t is less than 135, or you can say equal to, it is nothing but less than infinity. So that means what we have, that's the reason we have considered, just to have an understanding, because it will be moving till the minus infinity. Now that means what, we need to have it, the area between this point, so all this shaded area, so we need to have this shaded area. But as again, because of the symmetricity of the curve, we can have the same area here. And why are we doing so? Because we need to have use the standard normal curve, or a standard normal curve will gives us the area only in the positive sense, only in the positive values. That's the reason, because of the symmetricity, we could write down this particular thing as probability was 1.06 less than z less than infinity. And therefore this is nothing but again the same type of problem arise here. It's a 0.5 here. If it is a 0.5, this particular shaded area will gives us the value 0.5 minus this point, that is the region from 0 to 1.06, and therefore 1.06 will gives us the value as 0.3554, and therefore the value will be getting it as 0.1446 for this particular question. So every time we are trying to convert a variable into a standard normal variable, and then using the statistical table for standard normal, we can get the value of this particular. Now few things to note it down is as the symmetricity of the curve, as well as every time whatever the values we have got in the negative, we are trying to put it in the another part, so that we can easily visualize from the statistical table what exactly we need it here. Yes, and this is all about the particular first part. We'll be having the different type of questions in the part 2, and this is a self-observation slide wherein one question only I have given with 1, 2, 3, 4 options. Whatever the questions we have solved it so far, we can have it, and you can just try to solve these examples. If you are not getting it, please write me in the comment section. I will definitely give you the solution in the other sections. Yeah, and this is about part 1. Please stay connected, stay tuned for the upcoming session of part 2 for the normal distribution. Thank you. Happy learning.